Welcome everyone. This is a new session, and today we are going to talk about the permissions under a Unix file system. So, like how we can really check the permission of any file in Unix or directory permissions, and how do we really change those permissions. This is a very important topic as well for beginners as well as who do not understand the concept. So in Unix file systems, majorly or the mainly there are few entities in the Unix file system. The first one and the most common one is called regular file or files. Means one can create a regular file in Unix file system. Second type is directories or directory. Directory is another file type in Unix. It is just like a folder in Windows where one can store multiple subfolders or files. And there are some more, but majorly our topic of today would cover only regular file and directories. And third could be, let's say, links. But again, this session is mainly focused on regular files and directories of and their permissions. Okay, right. So hope so far it is clear that what are the entities of a Unix file system you can see. Now when we talk about any file or any directory in Unix, we majorly and its permission. So majorly we talk about the user or who is the owner of the file or directory. And the second one is group, basically the member or members of any specific Unix group. And the third one is others. And others would be anyone who is not the user or owner and not part of the Unix group, which I have said above. Okay, so far it may look confusing, but I'm going to explain what I'm trying to tell here. Okay, so in order to look for the permissions of a file, you will see these three aspects in a file or in a directory permissions. Okay, and there are three type of um, majorly there are three types of permissions. First is called R, which is read. Second one is called W, which is write. And the third one is called X, which is execute. So I will explain you what are these three permissions and what I'm talking about. So in order to create a file in Unix, the easiest way is you can use a touch command and create the file. Let's call it F1. This would create a 0 byte file. Okay. And after you create this 0 byte file, you can use a list command of Unix called ls and with the option L. This lsl option is going to show you the permission on that file F1. Okay. So let's do this step on Unix terminal and check. So first of all, we will create a file touch F1, and after that we'll do ls minus L, or I have a shortcut as well called ll for ls minus L, and I will do F1. Okay. So if you see the very first bit here, this is called permission of this on this file F1. Okay. So let's just copy this bit, long list the F1, and if the permission starts with a dash in the front, that means it's a regular file. Okay. Now we have to count three, or we have to look for next three bits. So what are the next three bits? Are W dash, right? And what are the another next three bits? It's R dash dash, and the last three bits are three dashes. Okay, so this one is the permission for the user or owner of this file. In this case, the owner is me, so the permission on this file is rw and dash. And if you look at here again, uh, so I have a read permission, I have a write permission, but I do not have a execute permission on this file F1. Similarly, the second three bits are for member of the group. So when you do a long listing of a file, okay, right, you will also find username and the group name. So group name can be any name, for example, my group. Okay, so this user is you. Okay, means the owner, the group. The second bit would be the group. For example, if the group is my group, yeah. So this my group, Unix my group. So this group would be a Unix my underscore group group. So this group may have members, okay, like you, like me, obviously, like myself, right? Or maybe user one, some other users, or user two. So these are called group members. So these would be the group members of this group called my group. Okay, group the member of the group has or have this permission, read, only read, and write and executes permissions are missing or not given. Okay, for the member of the group. So now you will ask me, okay, if I am the member of the group like myself and I do not have permission, I have only permission read, then what about this? But this is the preference, or this will take the precedence because I am the owner of this file. That means I still have read or read and write permission on this file. But the member, for example, user 1 or user 2, they will have the permission read only on this file f1. I hope it is clear now. And the third one is dash dash dash, which is others. So others have no permission of read, write, or execute. As I told you, what is others? Others are someone, or others are the people who do not have, who are not either the user or not the part of the Unix group. They are, they come into the others category. So in others category, you can see that they do not have any read, write, or execute permission, right? So this is the concept of basic concept of how do you check the permission of a file. Now let's create a directory in Unix. We create a directory in Unix by the command called mkdir, and here I will create a directory called dir. Okay, and now run the now if I do the long list, you can see the permission of this directory dir is this. Okay, this one. So what did I tell you before? If if the string starts with a dash, it is a file, but this time the string starts with D, and that indicates that it's a directory. Okay. Now what is the permission on this directory? As you know now already. So for the user, you have rwx. For group, you have r-x. And for others, you have dash dash x. Okay. Hope it is clear. I don't want to tell you again, but you can just check the explanation I gave here for the file. It applies for the directories as well. Okay. Now I will tell you also a little bit about which is called umask. Okay. Umask. So umask stand for user file creation mode mask. Okay. So there is a Unix command also. The Unix command is itself called umask. Okay, let's run it on the shell umask, and you can see there is a value which is a 4 digits here, 0026. So this is the umask value. Okay, and I'll tell you why, what is this umask. Okay, now and how it plays a role, right? What is umask? That's the question. Let's discuss that now. So in my case, umask is 0026, right? Okay. what happens is, so this is a this is a 4-digit octal number. Okay, octal number. In some operating system, you will see 0 to 6, like 3-digit octal number. Like Ubuntu shows you that 0 to 6. Right. So this mask or umask, it is basically uh, plays a role when you are creating a new file or a directory, and it plays the role in setting up the permission on those files. How? That's a question. Okay. Now, by default, when you create a new file in Unix, okay, the operating system sets the permission 666 on new file. Okay. Now question is, what is 666? Okay, I will come to that 666 very soon. This is a binary number, binary for the permissions. Okay, I'll explain you in a very short while. But for now, I will just explain you what is the concept of umask. So 666. Okay, and for directories, it is 777. So this is the default permissions given by Unix, but because there is a umask already in place, so to set the formula to set the effective permission on a file would become this 666 minus umask. Okay, and what is umask? 0 to 6, and that makes it 640, right? And similarly, the formula to set effective permission on a directory becomes 777 minus 0 to 6 equals 7, 5, 1. Okay, always remember that. Now, before you get more confused with this binary system, let me just introduce you what is this binary system and why and how you can link with or correlate with the permissions of a file or a directory. Okay, right. So I have already created a chart. Now we will talk about this chart and you can just pay attention. So basically you can see that the rightmost uh, column is octal value from 0 to 7. Okay, and there are three columns. First is read, second is write, and third is execute. Now, what is the equivalent of 0 in binary? It's 000, right? So that is the octal value. Octal value 0 to 7 is same as decimal value. So 000 means 0. Then binary 001 becomes 1. 0 is 1 1 0 1 0 becomes 2. 0 1 1 becomes 3, and so on, and the last one is 1 1 1, that becomes 7. Okay, and when you say 0 0 0, that means no read, no write, no execute, and the octal value is 0. Or when you say 1 1 1, that means you are saying read, give the read access, write access, and execute access to a file or a directory, and the octal value becomes 7. Okay, and you can have any combination. You can have this combination, or give a permission 4, and so on. So this is a concept of binary. And if I go back here, so these are the octal values. Okay, so that means when I create a new file, by default the permission which would set on the new file would become 640. And what is 6? 6 is this 110. That means read or write. So the file will get only read or write, right? Read or write for the user. For the group, it is 4, right? And what would be the 4? 4 would be this one, 100. That means only read, right? Read. And 0 is 0, which is no read. Or for others, it is 0. Means no read, no write, no execute. So let's check it on Unix. I will create a new file, F1, and check the permissions. So you can see permission are this. And you can see first is read write, which is 6. And then you have only read, which is 4, and dash 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 0, which is no read write or execute. So this read write and no execute is 6 for user. Read, no execute and no write is for group, and no read write execute is for other. Same concept goes for directory also. I hope this makes sense. If not, then just, you know, revise the video a little bit, see it couple of times, you will understand. If not, always you can ask me on the comment section if you have a doubt. Okay, now I will talk about chmod command, which means change mode or change permissions. So because when we create file for the very first time, we will get this permission, right? But you can always change the permission of this file by chmod command. Chmod command. The chmod command needs you need to give some permissions to change the permission, right? So for example, if you give 777, which are 3 octal numbers, right? Just like I have shown you in this chart. 777 is give read, write and execute all to this file F1. We change now permission to 777. After this, we will check again the long listing command with F1, and now you can see that we got read, write, execute for user, read, write, execute for group, and read, write, execute for other. Okay, and somehow Unix is smart enough to also show you this color now green, which means the execute permission for me, for the user. So that's how you can change the permission of a file. Okay, now there are other ways also to change the permission. For example, if I do chmod plus x, oops, chmod plus x and this file f1. Okay, so effectively what I'm trying to do is I'm setting this permission executable permission to user, um, group and others. Okay, but we already had this permission by 777, so let's just do something so that we can check it. So we'll do chmod, for example, 444 means set only read permission for user, group and other on this file f1. Okay, now let's check the long listing of f1. So you can see we have read for user, read for group, read for other. Now we will run the command again plus x on this file f1 and just clear the screen and do long listing. So you can now see that execute has come to user, group and other. It will not change the existing permission, but it will simply add execute permission also. Okay, so this is what X can do. And how can you remove it? The execute permission by one command. So you can do chmod minus X. Minus X would remove the execute permission from user, group and others for this file. And now long listing again. You can see now we have again removed. Similarly, you can add write permission to all by W and uh, run F1 here and check again. So you can see that by default when you do uh, write permission, if you with plus W, you will only set the write permission to yourself, but not to others. This is very important to understand. Now the question is, okay, if this is the case, then how can I give the write permission to everyone? So there is an option you can give as A equals, A is all, A equals to W, write on this file. Now let's check again. Now you can see I have given the write permission to everyone. But now one more thing is very important to understand, that when you use the assignment operator is equal to, then you will remove other permissions and you can only assign this W to all three section, means user, group and others. Okay, so this is very important to understand. Now question is, how do I control, uh, if I have, let's say if I give a permission chmod, let's say again 444 for this file. Okay, so now I have read permission only. Now for example, if I want to add write permission for user, group and other, how can I do? So if you write chmod, then you can also do one more thing which is called user plus W, comma, group plus W, comma, others plus W on this file. Okay, now check again F1. So you can see how we can add um, permission on each individually individual section by just adding these permissions like that. Okay, so this is also very good uh, method. Okay, So this is pretty much about how can you change the permissions of a file. Or same way you can also do on the directory, you know, to make it work. Now I will also talk about one more concept which is called recursive switch of chmod. So let's do this. Let me create a directory called d1, okay, d1, and if I check the permissions of this d1 is this which I explained before. Now let's go to the inside d1 directory by the cd command, change directory command. Here I will create two more directories, d2 space d3. So when I give a space, I can create multiple directories. So I am creating two more directories, d2 and d3, right? Like this inside d1. So I will go one level up. So now this d1 has two directories. How can you check two directories d1 has? You can do ls minus ll long listing of d1. You will see that the long listing of d1 will go inside d1 and tell you the status of d2 and d3. Okay. So by default we know what is the permission for d1. It is read, write, execute for user, read, execute for a group, and execute for other. How can we change? Let's do this. We will do chmod minus capital R, which is a recursive switch. What mean that means we are going to apply the permission for the main directory and all its subdirectories and file also, which are inside it up to all the levels. Okay. Here I will say here I will say that I have to add a write permission for the group which is missing right now in this d1 and d2 d3 also which is inside d1. So what I can do is I will write chmod, okay, minus r. For the group I will say give a w for the group, okay, assign the value w to the group, and then I will give the directory d1. Okay, let's see. So what do you see? That for the group permission I have given the w, but obviously I told you before also when you give assignment operator it removes other values but only assign the w, right? But the here my topic is to discuss about the recursive switch, right? So you can see if I long list now the d1, the d2 and d3 also have the same permissions, means just the w. So let's try something else. If I do chmod minus r, let's say I give this time I will say this time I will say give every give all the A is all, assign read, write, and execute to all and to the d1 directory. Okay, now check d1 permission. It has changed to all read, write, executable. And if you long list inside d1 also, you will see that d2 d3 also have got the same permission. So this is it guys. If you have questions, queries, feel free to ask me or make the comment and share your feedback. If you are happy to learn this session, just go ahead and like it as well as share with your friends or Do comment. Thanks everyone. Take care. Happy learning. Bye.